Okay, welcome. We are given this table and we're asked to complete the table. Draw the graph of y equal to sine 2x and y equal to cos x. Use the graph to solve cos x minus sine 2x equal to 0. So the first thing we have to do is to complete the table, because if you are given a table of value, before we plot the graph, we need to complete the table. Now, how do you do it? We keep on substituting the values of x and y. So like I'll just do one. I will paste the complete table to save time. So like for the first table, when x is 30 degrees, you see that for y equal to sine 2 times 30, we have sine 60. And sine 60 is 0.8660, which is 0.9. We're using one decimal place. So that's the same way. If you now substitute y equal to cos 30, cos 30 and sine 60 are the same, so we have 0.9. So that's how we fill up the tables. So for the second one, okay, we'll fill for 150. We have sine, when x equal to 150, we have y equal to sine 2 times 150, which is sine 300. We know sine 300 is in fourth quadrant, which is minus sine 60. So we have minus 0.9. So for cos, y equal to cos 150, which is the same as minus cos 30, which is minus 0.9. So that's how we do and fill up the table. So no need of wasting time. Let me paste the complete table. We now move to graph. So that's our complete table. And from this table, you notice that, remember, we have two graphs here. That's the two values of y. So before we plot the graph, we need to know the maximum and the minimum. So to know that's the boundary for the graph. So from this, x is settled because s is the same in both. So we see that the minimum is, from the table, is -1, and y maximum is 1. So with that, we've known that our graph will not exceed -1 and 1. So the maximum is 1 for y-axis and the minimum is -1. And for x, we have no negative values, so they are all positive values. So this will help us to locate the origin. So that's the essence of knowing the minimum and maximum. So we are getting our axis. So let me place this for y. So we are getting our x and y axis. Okay. So as you can see, I think the origin will be better here. Let's check. If I count 1, 2, 3, 4. 1, 2, 3, 4. So the origin, the best place to locate the origin is here. So our origin is here. That's 0. Why our x-axis So that's our x-axis. Another name for x-axis is y equal to 0. Why this is y-axis or x equal to 0. So we've located the origin, we've located the y and the x-axis. Let's now locate that's the maximum. Let's put the points. So this is, if I count 1 2 3 1 2 3 4, so this is my 1, meaning here is 0.5. This is minus 0.5. This is minus 1. Yx, we are moving in intervals of 30, so we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. So we've located that's the table for x, that's the values of x and the values of y. So let's now locate the points. So here, when x is 0, y is 0, I'll plot the first one and join before plotting the second one, so that won't make mistake. So when x is 0 for the first one, now let me just copy and paste the table where it will be. You will see it. Let's copy and paste. Okay. When x is 0, y is 0. So this is the origin. Let's use so that's it. That's the first point. When x is 30, y is 0.9. And we didn't get something here. Let's try. Remember, to get each of these grid line, we need to calculate it. Yes, each of these small minor grid lines. We've known the major one. We are going 0 point. Let's get each of them. And how do you do it? Each grid line for y is the interval we are moving over the total grid line to that interval. So we are moving in interval of, because the scale here, the scale is either 2 cm to 0.5 units. So the interval is 0.5. We are moving in 0.5 over the total grid line to that 0.5 is 10. So each of these will be 0.05. Yes. So each of these each grid line is 0.05. So to locate a particular interval, that's the total, any total grid line now, then y will be interval over each of the grid line. So meaning that the values of y, each time I'm looking for it, if it's not seen visibly, I would divide that value by 0.05. That's it. Like if I want to locate 0.9 over 0.05, that gives me the total grid line. To get 0.9, I have to do 0.9 divided by 0.05 so that I can locate the total grid line starting from the origin. So if I do 0.9 divided by 0.05, I have 18. So I'll move up to 18. So we'll count. When x is 30, I'll move 18 grid lines up. So 5, 10, 15. 16, 17, 18. So that's my 0.9. So, and again, this is 60 is also 0.9. So is here. So in order to, okay, for 90 is 0, see 90 0. For 120 minus 0.9. So since 18 up is positive, 18 down will be negative. So 5, 10, 15, 5, 10, 15, 16, 17, 18. So for 180, for 150 is also that. So this is that. For 180 0, that's it. For 210 is 0.9, that's positive. We'll go up 1, 2, 3. For 240, that's same positive. That's 1, 2, 3. For 270 0, so we'll go down 0. For 300 is minus 0.9, so we'll go down 18 times. 1, 2, 3. For 330 is the same, negative 0.9. 1, 2, 3. For 360 is 0. So we join. We'll take different ink. Okay, let's take green. So we're joining the point. That's it. That's it. That's it. We are moving. That's it. 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 And finally, so that's it. Let's change the color to green and let's make the line tick. So that's the first graph. We've done y equal to sine 2x. So let's label it. This is y equal to sine 2x. So let's draw for y equal to cos x. So we'll locate the points. Let's use blue. So when x is 0, y is 1. So 1. See, x is 0, y is 1. So that's the point. When it is 30, 0.9. So the same point as that. When it is 60, is 0.5. So 60, 0.5. That's the point. When it is 90, we have 0. That same point. When it is 120, you have minus 0.5. So 120 minus 0.5 is down here. It's visible. When it is 150, we have minus 0.9. 9. So that same point here. When it is 180, we'll have minus 1. 180 minus 1. So we have this. So when it is 210, we have minus 0.9. 210 minus 0.9. Remember, 0.9 is 18 down here, 5, 10, 15, 16, 17, 8. So that's for 210. When it is 240 minus 0.5, 240 minus 0.5 is here. 270, that same point. 300, 0.5. 300, 0.5 is up here. 330, 0.9. 330, 0.9 will be up. Let me move this to this side. Just move it after we'll continue. So when it is 330, we have 0.9. 330. 0.9 is 18 up, 5, 10, 15, 16, 17, 18. And when it is 360, we have 1. So 1 is here. So that's the point. So we'll finally join. Let's join the point. So we don't need this again. We don't need it. So let's join our points. So let's get our curve. So we are joining. We started from this. We'll move to this. We move to this. We move to that. We move to that. The next point. We move to the next point. We move to the next point. We move to that 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 point, and finally to 360. So that's our curve. Maybe let's change the color. Let's change the thickness, and let's change the color. That's okay. So that's our second graph, which is y equal to cos x. Y equal to cos x. So let's label. We have, this is y equal to cos. So the next thing is to use it and solve the next question. They say use the graph and solve. We've done the first part, we've completed the table, we've drawn the graph. They say use it and solve cos x minus 2x equal to 0. Use the graph and solve cos x minus sine 2x equal to 0. So whenever you're asked to use a graph to solve a particular equation, what you have to do is to transform. So we're going to transform the given equation to look like the plotted function. So if you notice, the graph we plotted y equal to sine 2x and y equal to cos x. So we're going to transform this to look like these two graphs. So let's start. We have cos x minus sine 2x equal to 0. So moving this to the other side, we have cos x equal to sine 2x. And what's the meaning of this? This means the point of intersection maybe we have more than one point, so the points of intersection of the two graph function, that is y equal to cos x and y equal to sine 2x. So that should be the answer. So we'll go over to the graph and locate the point of intersection. So let me locate it. Let's use black. So you notice that they intersected here, so let's call it point A. So that's the solution. The x value, which is 30, that's the solution B. That's the solution, which is C, at point C, which is x equals to 150. So we have 2/7, so which is D. So the answer is now the points of intersection of these two graphs, which are 30, 90, 150. So which are 30, 90, 150, and finally 30, 90, 150, and 2/7. So these are the answers. So it's a very tricky question, but it's simple. Thank you.